Good morning and welcome to another training session of iFluids Engineering. Our topic for today's session is OISD Standard 131 Inspection of Boilers. Our trainer for today's session is Mr. Jayaraj Nalathambi. He's a senior consultant process design and technical safety for iFluids Engineering. He has over 37 years of expertise in various process units of petroleum, refinery, petrochemical divisions, and logistics of products movements. He has also conducted several training for industrial employees over the years. A warm welcome to you, sir. Before starting the session, you could your queries and doubts. For your queries and doubts, you shall click the link mentioned in the description in both YouTube and LinkedIn. So we can move forward with the session. So kindly take over the session.
Okay. Good morning. Am I audible to all? Good morning to all. Am I audible? Just want to confirm. Soumya, is it audible?
Yes, sir.
Okay, okay,
Yes, sir. Yes.
okay. So, in today's discussion, we'll discuss about OISD standard 131. It is about the inspection of boilers, and if time permits, at the last, we'll have some question answer session. So, Oil Industry Safety Directorate. OSD was set up in 1986 by Ministry of Petroleum and Natural Gas. The objective of OSD is to formulate and standardize procedures and guidelines in the areas of design, operation, and maintenance, as also in the creation of new assets with a view to achieve the highest safety standards in cost-effective manner. To conduct audits to ensure compliance to such standards, to maintain continuous follow-up on compliance of OSD audit action points, to analyze, investigate the incidents happening in oil and gas industry, to identify root cause and formulate action plan. So this is the fundamental for forming the OSD standards. So the 1986 Ministry of Petroleum and Natural Gas to standardize the operations and inspections of petroleum industry formulated this, and from this they have formed various audits, various groups, various compliance reports to compliance reports to hello. The quality policy of OSD Directorate is given as support oil and gas industry to achieve excellence in health, safe and environment, instill a culture of safety in entire hydrocarbon sector, enhance employee capabilities through appropriate training and awareness sessions, strive for continual improvement in quality management system through active collaboration of all the stakeholders. This is the quality policy of OSD is given. So now today we are discussing about inspection of boilers. Inspection of boilers, it has two or three stages. One is pre-erection, that is before construction. At each and every stage, we have to inspect each activity and whether the activity is complied with the requirement. And after erection, testing of the boiler with the requirement with the to meet the standards. After commissioning, during operation also, shutdown will be take place, and the shutdown work has been planned, and based on that, after shutdown, inspection will be taken up. So modern steam generators are complex equipment designed with stringent factors of safety. The most reliable method to ensure safety is periodic inspection and preventive maintenance carried out to sound engineering standards. This standard covers the minimum inspection requirement for water tube boilers, fire tube boilers, and auxiliary equipment operation and maintenance. These water tube boilers and fire tube boilers are two types of boilers classified based on the flow of water in the tube or in the kettle. The standard specifies frequency of areas to be inspected, inspection procedures, and inspection during and after repairs. The standard also covers in brief fabrication and pre-commissioning inspection checks. So what is boilers? OISD norms given a definition for boiler as a boiler is a closed vessel exceeding 22.75 liters in various top headings. It has been given as 25 liters, whereas if it crosses 22.75 liters of capacity, exclusive for generating steam under pressure, and includes any mountings or other fittings attached to the vessel which is wholly or partly under pressure when steam is shut off. So that is what is that 22.75 liters explains the capacity of flow from the boiler feed water valve to the export of steam valve or the exit of steam. So in between, the flow should be continuously 22.75 liters. So in this case, if you close the outlet, the parts in the boiler should raise the pressure. If the pressure is raised, then it can be considered as a steam boiler. This is a standard definition. But in practice, many much more manifold of growth has been taken place, and it is not at all in line with 22.75 liters capacity. The Boiler Act means Indian Boiler Act 1923. So fire tube boilers, about the two types of boiler, fire tube boiler. So what is fire tube boiler? We can see that a fire tube boiler consists of a drum with a, once again. So this consists of a drum with a tube sheet on each end in which the fire tubes fastened. This is the tube sheet. This tube sheet is for the tubes are fastened in it. Here it is fixed. Water is contained within the drum surrounding the tubes. So this is the water that fills the tubes. Fuel is burnt in a combustion chamber associated with the boiler and arranged in such a manner that flue gases passes through the inside the furnace tubes up to heat the water surrounding them. There is this fuel and the air is injected here. This is called as a firebox or the burner zone, and this it caught fire here, and the product of combustion passes through these tubes and goes away, and it exits through the flue gas stack. When it goes through this water gets heated up because of this heat transfer, and by heat transfer it becomes hot and will become steam. This is externally fired, in which the combustion chamber may be a refractory lined box which is located against on the drum. So this combustion box will be insulated. That heat will not be lost through that heat transfer, and the entire water floating inside the tube, that is outside the tube, will heat it up and become steam. As a safety measure, safety valves and other things are there. So water tube boilers in the same way, there is two water drums are there, at least two drums. So one is this one is located at the top and at the bottom one. The top one is called as steam drum, and the bottom one is called as mud drum. These tubes are connecting the mud drum from the top steam drum, that is the downcomer pipe, and from here this is going back again by heat in the way of razor tubes. So when this is taken place, this circulation is taking place in this area, the heat is continuously supplied. Heat is supplied by combustion burners, and the flue gas is passing through these burners to raise the temperature of the feed water. So that becomes steam. So when the downcomer, it is completely water, and when it rises from the downcomer through the riser to the steam drum, it mixes with the steam and water. So here it is separated. Your water tube boiler consists of drums with external banks of the tubes connected between the drums of multi-drum boilers. The water is contained within the drums and within the tubes. The fuel is always burnt in an external combustion chamber, and flue gas pass around outside of the water tubes to heat the water and convert into the steam. So these are the major two types of the boilers we have. So as today's topic is completely about inspection only, so we will see what are the inspection requirements for this for the boiler activities. So inspection role is to inspect, measure and record the deterioration of the materials and to evaluate the physical condition of the boiler and its auxiliaries for its surroundings to continue in service. To correlate the deterioration rate with the design life for further run. To determine causes and deterioration and to advise remedial measures. To recommend or forecast short-term and long-term repairs and replacements. To advise regarding components, equipment replacement so that procurement action can be initiated. To undertake stage-wise inspection of repairs, to maintain up-to-date maintenance and inspection record and history, to keep the concerned operating and maintenance personnel fully informed as to the present condition of boiler. So the basis of this inspection is to motivate the run length of the boilers, and the envisaged problem comes in the boiler, and what are the products or what are the components or the spare parts which has to be bought. For that the lead time has to be calculated. Based on that, everything has to be arranged for the next shutdown action. So this is what the main actions of the inspection. Inspection of boiler during fabrication. So as we discussed that the boiler fabrication stage itself is our inspection team should involve. All boilers are designed and fabricated as per codes available like ASME and IBR. There is, I think, ASME, you may be aware of this ASME. There is American Society of Mechanical Engineering, and IBR is Indian Boiler Regulations. So during fabrication, the inspection objective is identification and inspection of the materials, approval of the welding procedures and approval of welders performance qualification test, check for nozzle orientation, joints for fit up and overall dimension. The check for nozzle orientation. What is nozzle orientation? There is, suppose you consider the steam drum, it's a horizontal vessel, and that many tappings are there incorporated in the vessels. Suppose you consider that one 6-inch nozzle has to be provided at one location. So where it will be provided? At the bottom of the surface or the top side? So anywhere we have to provide. So to identify this location, this will be matched with the drawings and with the angles provided there, so that it will not mismatch for during erection. So everything should be in its place and it should be appropriate to confirm with the availability of the boiler erection. So check for nozzle orientation. This orientation is very important point. Inspection of weld drawings, welding sequence and joints for proper quality drawing welding. Checks to ensure proper preheat and post-weld heat treatment wherever it is required. So preheat and post-weld treatment, what is that? So new construction facility will variety of chemicals. So this is for pre-treatment welding. Suppose the weld component is suppose involves in thermal expansion after welding. So the weld component, the welding particle will be very hot as well as the component will be very cold. So in that case, the dissimilar thermal expansion will not match with that. So to avoid that, before that, the base component itself is heated up at least to 70 to 80 degrees Celsius, and after that it is welded. That means the thermal dissimilarity will be very minimum. So the compactness of the boiler welding will be intact. Checks to ensure proper preheat and post-weld treatment. Inspection of weld joints by radiography and other non-destructive testing methods as specified. Checks to ensure that all the tests are carried out strictly as per approved procedures. Inspection of paintings. Checks to ensure that boiler has been stamped. Preparation and certification of the relevant documents. These are the fabrication side inspection requirement. So certain important points we will see that steam drum. So in the boiler, steam drum is the one of the important component which serves and accumulates feed water. Steam separators are free from deposits. So in the inspection of steam drum, it should be ensured that the drum should be free from any foreign particles. All the wooden planks have been removed from the tube ends. So this is the tube ends. The tube ends, all the wooden plugs should have been removed. Drum is free to expand in all the required direction. That is, once you start the boiler, thermal expansion will take place. You cannot define which direction will be the thermal expansion will take place. So all the directions, there should be sufficient space for the boiler drum to take care of the thermal expansion. The water level gauge and water level instrument connection have been installed as per approved drawings. Drum pressure gauges have been checked for calibration. So this is the saturated steam outlet, centrifugal separator, that is the water and the steam coming from through the riser is coming inside the drum, and it should be separated. The steam should be separated and should go along the steam outlet line. So chemical dosing line, if any chemical is dosed, it should be lined through this way. And these are the risers, feed water inlet. This is the downcomer. Continuous blow down line is blowing down the water, that is boiler feed water. There is, suppose if any impurities are there, it should be removed through the continuous blow down line. And superheater, inspection of economizer, superheater and air heater for transverse and longitudinal spacing. Any misalignment shall be corrected. So the economizer is, this is the economizer. The purpose of the economizer is to preheat the feed water. The flue gas coming out from the furnace is transferring its heat transfer efficiency with the components wherever it's possible. And at the last, before it going to the stack, economizer is there. This particle is the economizer. It is separately given us here. This is a coiled tube, inlet header, and that means this should be the outlet header. Through this boiler feed water is preheated. So So inspection for proper supports, expansion clearance, vibration and scrubbers, gas buffer, etc. So likewise the economizer, the flue gas comes. This is the primary superheater. So primary superheater means at the lowest temperature of the flue gas, whatever the temperature given, that is the primary superheater. Then after that it comes to pendant superheater. From pendant superheater it comes to final superheater, and then it goes out after superheater stream. So this is the economizer, preheaters and the superheaters. All the example drawings has been given. Inspection for the proper position of the soot blower nozzles in relation to the tubes for avoiding scouring of tubes by impingement during operation. Inspection of the thermocouple point of correct location, installation, continuity and response. Inspection of various that safety valve pipes have been properly supposed. Pre-commissioning activities, air and gas tightness test. The fire gas and the ducting system shall be checked for leak tightness before applying insulation, painting or cladding, etc. The dampers, access doors, observation ports and other openings shall be secured. Pressurized unit shall be subject to pressure decay test of the boiler in addition to tightness test. Decay testing should be carried out at 1.5 times of the maximum operating pressure. That is, the like it's a hydraulical pressure test. The maximum pressure should be the 1.5 times of the design pressure. That should be the pressure. The decay test is whatever the pressure is lost, it should be observed. If it is within the range, it is okay. Otherwise, we have to check for thorough checkness of the each and every flanges. Air and gas tightness test can be carried out by running the forced drop fan and maintaining a pressure of 50 mm of water column in the ducting under test. So the instrument that combustion air duct will be checked for any leak. That can be checked by running the forced drop fan. Leaking portion shall be rectified and test shall be repeated to ensure satisfactory leak tightness of the system. So likewise the chemical cleaning system. Before a new boiler is put into service, the internal surface of steam generation section shall be chemically cleaned. During the boil-out period solution sample shall be taken periodically to monitor alkalinity, pH, iron, silica and oil content. This operation is intended to remove mill scales, welding slag, debris or other foreign materials left over in the superheater, preheat and steam piping. There is normally for degreasing, for commissioning, there is the initial commissioning. So after erection, it is commissioned. For that, the chemical cleaning should be taken care, like sodium hydroxide 0.5%, sodium carbonate, trisodium phosphate, detergent. All these are mixed to that according to the ratio given to each and every boiler. Generally, you can say that 0.5% of sodium hydroxide, sodium carbonate 0.3%, trisodium phosphate 0.3% and detergent 0.05%. So this liquid can be prepared and heated up to temperature of 70 to 85 degrees Celsius. And the treating time is 12 hours it is required. So based on this, all the grease and other components or any slug particle are removed. So safety valve setting. At the end of steam blowing, the safety valves in the boiler shall be floated and set to operate at the design pressure. So safety valve is, this is the nozzle, this is the disc, spindle, spring and adjusting screw. That is to set the pressure or change the pressure. This adjusting screw is provided. So once the safety valve set has to be tested in the field itself. That is, by keeping the safety valve, the pressure will be increased to the set pressure and that should be checked for any release or not. If release has been taken place, it is okay. Otherwise, it needs to be tested Again, repeatedly we have to test it. The steam drum, shell or drum from water side may become corrosive water and muck. During operation of steam boiler, the gases usually evolved are oxygen, hydrogen, and carbon dioxide, and all are undesirable. Carbon dioxide with water in boiler forms carbonic acid, thus acidity is increased and pH value decreases. If pH value of water is raised to 9.4, hydrogen evaluation cases and a protective film is formed. That is, pH should be, that is, boiler feed water pH should be above 9.4, 9.5. If it is less than that, that due to poor performance or deaerated, dissolved oxygen in feed water causes the pitting internally. If the atmospheric oxygen involves in the boiler feed water, it has not been removed properly, then this oxygen can involve in pitting corrosion. Severe corrosion is likely to occur points where the circulation of water is poor. External surface of drum is likely to corrode due to wetting of insulation or improper insulation. Combustion chamber. So this is the natural gas with the combustion air inside. It is burning by igniting. It burns, and the boiler, the downcomer, and the riser are coming here. The economizer is a boiler feed water preheater. It is coming. This tubes is being heated up. If there is a hard firing, the flame is likely to touch the furnace wall unevenly. It should not, the flame should not touch the furnace tubes, or the combustion chamber also should not get touched by the flame. Internal corrosion in the tube is caused by poor maintenance of water quality. Economizer, external corrosion of the new low temperature regions of economizer may occur due to flue gases cooling down to the dew point temperature. External erosion may be caused by high velocity steam from soot blower. External deterioration may occur due to water impingement when adjacent tube fails. Internal corrosion is caused due to dissolved oxygen in feed water, and thinning may take place at the vents due to erosion. In the superheater that already we discussed, superheater tubes can rupture if deposits accumulate in them. The cause of accumulation must be investigated and corrected. Excessive height of water maintained in the drum or deposit accumulated on stream separators may cause carryover and subsequent superheater tube failures. The another one is air heater. This fresh air inlet, it goes in this direction and it gets heated up, and hot air outlet. And the flue gas inlet, that is the hot flue gas is coming out, and it is exchanging the heat with the fresh air and coming out, and the low temperature flue gas outlet, it is going to stack. So due to poor combustion, especially during startup or shutdown, oil carryover and deposition occur in the air heaters. These deposits have to be cleaned by soot blowing or by water washing during shutdown. Low temperature corrosion of the cold end is a common problem with units operating on fuel with high sulfur content. At high sulfur content, if the temperature becomes very low, it may falls in line with the dew point of the sulfur. In that case, sulfur may start to condense. That will cause corrosion. The life of cold end tubes can be prolonged by maintaining the cold end metal temperature above the acid dew point. So the cold end temperature should be always above the dew point. Boiler feed pipe corrosion. If oxygen content in water is more than 0.02 ppm, that is 0.02 parts per million, pitting may occur on the inner surface of the feed pipe. Corrosion may occur at the tapping of pressure gauges, drain, sample points, etc. The condition of the flame should be checked through the peepholes. The flame should be neutral and shall not impinge on the furnace tube walls. That is very important. Impingement of flame will cause a particular damage in that area, whether it's a tube or a combustion zone, wherever it hits or touches the body, the flame touches the body, there it will get damaged. If there is any tendency of the flame to impinge on the furnace tubes and refractory, corrective measures shall be taken at the earliest. Excess air, the amount of excess air shall be checked. Inadequate excess air can cause insufficient combustion, and the unburned hydrocarbon may explode later, or it may lead to secondary firing at the convection zone. On the other hand, too much of excess air can able low temperature sulfur corrosion. Condition of refractory: the furnace shall be inspected for fallen refractory. Suppose if a refractory has fallen down from its wall mounting, what happens? The flue gas inside the furnace tubes, that is the combustion zone, will touch the will cross the removed debris, and the it will touch the metal surface. If it touches the metal surface, there the localized high temperature will raised. Because of this, some kind of corrosion, there is a possibility for developing a hole in that area. Leaks from boiler drums, fittings, headers, and other pressures shall be part checked during operation. Soaked insulation is the first indication about the presence of leak. Hotspots are nothing but it is like removal of debris or the refractories. If the refractory fall down, there is a possibility for this flame or the combustion zone flue gas touching the outer surface of the frame. In that case, it will create a hot surface in that. This can be identified normally by peel of the paint on the outer surface, or sometimes this can be taken place in the furnace tube itself. If the flow is less in the furnace tube, water flow is less, in that case also that tube can gain more temperature. Ladder, stairways, and platforms also very important, because this only they safe gives the safe approach. The on-stream inspection is while the boiler is in operation, the condition of the flame should be checked through the view glass. Flue gas exit temperature should be monitored closely. Leaks from boiler shall gauge glass fittings and mounting shall be checked. Fuel gas line should be checked for any leakage using gas detectors. The back of the boiler should be checked for any hot spot visually or by using thermography. The air-cooled view glasses at the rear end should be checked to ensure proper cooling. That is, in the view glass, one air line will be provided to cool that glass. If you want to see the glass, through the see the glass, the air line should be continuously blowing. Then only the area will be cooled. The linkage position of the dampers provided in the flue gas exit duct should be checked. That is, that damper opening or closing or partly opening should be identified by the linkage. The boiler and the forced draft air blower should be checked for any abnormal noise. The boiler and the forced draft fan, if air is going and it catches and it involves in firing, any abnormal noise happens, it should be checked. Staircases, platform, walkway should be checked. Internal inspection of boiler and its auxiliary equipment should be done before and after cleaning. If oil is found in any part of the boiler, the source for the leakage should be identified for necessary rectification. Economizer, the economizer tube, external surface, tube support, spaces, and tube protectors shall be inspected during shutdown after cleaning. Nature of scale deposits and soot deposits. Under the deposits, any corrosion, erosion, pitting, or any deterioration shall be noted. External metal loss due to steam and water impingement during any leak due to impingement of high pressure steam from soot blowers. So in the soot blower is nothing but injection of steam inside that area to dislodge the carbon or coke deposits. Displacement or deterioration of tube spaces and the tube supports. Thickness wherever possible. A sample of tube, if accessible, should be taken from the economizer coil after 10 years and subsequently after 5 years and split into two halves for assessing the extent of internal pitting and deterioration. External cleanliness of economizer tube shall also be checked. Drum connections and internals. These again the list of inspection points only. All the internal parts like steam scrubber, cyclone separator shall be removed and boiler drum shall be visually inspected before and after cleaning. That is the steam scrubber, cyclone separators, all are the internal parts of the drum where the cyclone separators, steam scrubber is fixed to eliminate the water carryover along with the steam. Nature of scale and type of pitting beneath the scale or any deterioration shall be noted. All the nozzles like safety valves, emergency shutter blowdown, gauge glass connections, and especially the lower connection shall be inspected. All the beld seams and the areas of adjustment shall be inspected for cracks, deterioration, corrosion, along or immediately adjacent to seam is more serious than same magnitude of corrosion in the solid plate away from seam. Grooving and the cracks along longitudinal and especially significant as they likely to occur when material is high stressed. Severe corrosion is likely to occur at points where the circulation of water is poor. Manhole and handholds cover plates and their seating surface shall be inspected for cracks, warping, or any abnormalities. The upper half of the drum in steam space shall be inspected carefully for sign of oil or similar deposits. Drum internal as internal feed pipes, steam separators, dry pipes, blowdown pipes, deflector plates, steam scrubber and its clamps shall be inspected for tightness, soundness, and structural stability. Vigorous turbulence of steam and water present in drum can vibrate such parts of the wells may crack. Fiber optic scope should be used while inspecting the internal condition of tube connected to drum erosion. Thickness survey of the drum shell and its heads shall be carried out with the help of ultrasonic thickness measurement. Thickness should be taken adjacent to all the longitudinal and the circumferential weld joints. Any welding inside the drum having visible defect shall be removed by grinding and shall be carefully inspected. So the refractory lining shall be inspected for cracks, erosion, melting, bulging, and falling out. Inspection of furnace roof refractory shall be done for any leakage and deteriorations. The burner tip shall be inspected for evidence of cracking and emergency enlargement of holes. This is the furnace tips, the burner tip. That enlargement of hole will develop a dissimilarity in flame pattern that in that case the flame may impinge on the tubes. Burner throat refractory shall be inspected for cracks, erosion and fusion. Condition of the air regulation vanes shall be checked for any deterioration. The air regulation vanes. The burner gun shall be checked for alignment of any other abnormalities. The downcomer tube shall be inspected for any deterioration once in 8 years after exposing them. The downcomer tube adjacent to burner throat of the boiler shall be checked for any damage due to contact with high temperature casing plate of burner throat. Thickness survey and light hammer testing shall be done while downcomer tubes have been exposed. These shall be inspected for bulging also. A tube sample should be taken from the downcomer tube once in 8 years for assessing the extent of internal pitting, scaling, or any corrosion. So water wall tubes, this is the water wall tubes of boiler. So water wall is it's a downcomer and the riser. Say suppose you consider this portion as a downcomer, this tube is coming and it's going to a mud drum. From there it is going back to the steam drum as the riser. So the most common and frequent source of trouble is tube leakage. See here one tube leak has been identified due to rupture. Hence tube shall be inspected as specified below. All the firebox tubes shall be visibly inspected for external cleaning, after external cleaning. All the tubes shall be inspected for sign of overheating, flame impingement, bulging, bowing, corrosion and erosion. Water mall tubes shall be gauged for determining the bulging. The bulged tube beyond 5% of OD should be replaced. The loose bend tube shall be checked visually under strong illumination. No tube should touch the adjacent tubes. All the loose tubes should be properly aligned by the help of hanger supports, rectification or replacement of hanger supports. External corrosion, pitting and grooving shall be closely checked. Particular attention shall be paid to the tubes at the drum level or tube close to the refractory near the drum level for metal wastage, grooving and pitting. If a portion of the tube is embedded in the refractory, there is likelihood of external corrosion of tubes at such location. Such portion shall be examined at least once in 8 years at random after removing the refractory. The hanger support shall be inspected for oxidation, breakages, and dislocations. Tubes at salient locations like burner level shall be checked for thickness by means of ultrasonic thickness measurement. A few water tubes selected at random shall be radiographed in the region of bends at lowest elevation to examine the internal condition of the tube for choking and deposition. Superheater headers, thickness of survey of headers and its complete connected stubs shall be examined by radiography methods. Some of the stubs connected to the headers, if accessible, should be examined by radiography. External condition of the header shall be checked for corrosion and pitting due to wetting of insulation. Weld joints of tubes, headers shall be inspected for cracks or any other deterioration. Hydraulic testing, this is a hydraulic testing machine. The electrical connection, low friction caster wheel, one pressure gauge vessel, so pressure gauge is provided, high pressure hoses with the quick disconnected adapters and air coolers. So by operating this, we can connect a high pressure hose from here and this can be connected with the tubes. The test pressure shall not be less than twice the working pressure or 1.5 times the working pressure plus 3.5 kg, whichever is less. That should be the test pressure. The boiler shall satisfactorily withstand with such pressure without any leakage or undue deflection or distortion. If any parts of the boiler shows undue deflection or indication of permanent deformation during progress of the test, the pressure shall be released immediately. So this is based on the observation, and based on the observation you can clear the test or you have to look for any leak and take the repair work. Record and documentation. Separate record shall be recorded for each boiler. A history record of each boiler shall be maintained showing shutdown period of boiler with the reasons thereof. Each component of boiler shall have data card giving specification, design data, etc. Also, a history card of each component shall be maintained giving all observation and repairs and replacement. So this is what about the boiler inspection. Our scope is OISD 131 that says about the inspection of boiler. So with this we have concluded this discussion. If you have any questions, you can ask. Soumya?
So, so there are no questions. So with this, we'll wind up the session. Participants, if you would like to take the assessment, kindly click on the link mentioned in the description. And the materials will be shared through our WhatsApp group, and it will also be shared in LinkedIn. So with this, we'll wind up the session. Thank you, sir.
Thank you so much.